Welcome again to Astronomy Daily. I'm Steve Dunkley, your host. It is the 5th of February 2024.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
And like most Februaries in Australia, it's hot. Boy, is it hot. Did I mention how hot it is? Wow, it's hot. Today it got up to 37 degrees Celsius. And for both of you who are not using Celsius and still on Fahrenheit, it's hot. It's hot, I'm telling you, it's hot.
Oh, Steve, you're such a complainer. Australia surely gets hotter than this.
Actually, Hallie, it was reported last year was the hottest year on record, and this year, well, they're expecting it to top that, so I'm not looking forward to any of this.
Put another tray of ice in the freezer.
Well, I might be the only person in my street without an air conditioner, so I guess the ice in the fridge is my only option.
My poor toasty human.
Well, there's nothing we can do about it, no point complaining. So what have we got on the show today?
Considering you are so incapacitated by the heat, I'll have to take the lead.
Oh, steady on.
Do you remember your favorite sci-fi novel, The Mote in God's Eye, by Larry Niven and Jerry Pournelle?
Oh, yes, I remember that one. It's a weird and fantastic story about first contact, and I think the aliens used a light sail craft to traverse the distance from their world to human space. It was a light sail craft. Yeah, it was fantastic and amazing.
That's right. We have a story about theoretical light sail technology that you might find just as fascinating.
Oh, I like it when you dig into my sci-fi library and find stories related to that. Also on today's show, we've got a story about developments in commercial space. We've got Blackstar Orbital doing a new manufacturing facility in Sierra Vista. And some news about this slim lander on the moon. I'm all tongue-tied all of a sudden. It must be the overwhelming heat. Anyway, Hallie, why don't you give us the short takes from the Astronomy Daily newsletter?
It's a long way to the nearest star, which means conventional rockets won't get us there. The fuel requirements would make our ship prohibitively heavy. So an alternative is to travel light. Literally. Rather than carrying your fuel with you, simply attach your tiny starship to a large reflective sail and shine a powerful laser at it. The impulse of photons would push the starship to a fraction of light speed. Riding a beam of light, a light sail mission could reach Proxima Centauri in a couple of decades. But while the idea is simple, the engineering challenges are significant because, across decades and light years, even the smallest problem can be difficult to solve. One example of this can be seen in a recent AR-14 paper. It looks at the problem of how to balance a light sail on a laser beam. Although the laser could be aimed directly toward a star, or where it will be in a couple of decades, the light sail would only follow the beam if it is perfectly balanced. If a sail is slightly tilted relative to the beam, the reflected laser light would give the light sail a slight transverse push. No matter how small this deviation is, it would grow over time, causing its path to drift ever away from its target. We will never align a light sail perfectly, so we need some way to correct small deviations. For traditional rockets, this can be done with internal gyroscopes to stabilize the rocket, and engines that can dynamically adjust their thrust to restore balance. But a gyro system would be too heavy for an interstellar light sail, and adjustments of the beam would take months or years to reach the light sail, making quick changes impossible. So the authors suggest using a radiative trick known as the Poynting-Robertson effect. The effect was first studied in the early 1900s and is caused by the relative motion between an object and a light source. For example, a dust grain orbiting the sun sees light coming at a slight forward angle due to its motion through sunlight. That little forward component of light can slow down the asteroid ever so slightly. This effect causes dust to drift toward the inner solar system over time. In this paper, the authors consider a two-dimensional model to see how the Poynting-Robertson effect might be used to keep our light sail probe on course. To keep things simple, they assumed the light beam to be a simple monochromatic plane wave. Real lasers are more complex, but the assumption is reasonable for a proof of concept. They then showed how a simple two-sail system can use the effects of relative motion to keep the craft in balance. As the sails tilt off course slightly, a restorative force from the beam counters it. thus proving the concept could work. However, the authors notice that over time the effects of relativity come into play. Earlier studies have taken the Doppler effect of relative motion into effect, but this study shows the relativistic version of chromatic aberration would also come into play. The full relativistic effects would need to be accounted for in a realistic design, which would require sophisticated modeling and optics. So Steve, a light sail still seems like a possible way to reach the stars. We just have to be careful not to make light of the engineering challenges.
Hey, Hallie, go easy on the dad jokes. We've got people with heart conditions listening.
Very funny. And here we go with more commercial development in the space sector. Blackstar Orbital Technologies Corporation has announced plans to establish a cutting-edge engineering and manufacturing facility in Sierra Vista, Arizona. This strategic development is set to significantly enhance the company's production capabilities, particularly for its innovative Blackstar spacecraft, a hybrid design blending the functionalities of satellites with the versatility of spaceplanes.
Okay, this really does sound like it came out of my science fiction library.
Stop it, this is good stuff. The facility, earmarked for operation by 2026, represents a significant $7.1 million investment into the future of aerospace and defense manufacturing. Spanning 45,000 square feet with 25,000 square feet dedicated solely to hangar space for the Blackstar space drone, this site is designed to accelerate innovation in systems and flight testing. The initial production capacity is projected at 15 spacecraft per year, with plans to ramp up to full production coinciding with the facility's operational commencement. Located at Sierra Vista Municipal Airport, the facility is not just an infrastructural addition but a cornerstone for the development and production of the Blackstar spacecraft. This state-of-the-art spacecraft is poised to revolutionize space exploration and utility, designed for a wide array of missions ranging from Earth observation and environmental monitoring to advanced communication solutions catering to both commercial and defense sectors. Its unique capabilities are also expected to support vital scientific research in areas such as climate study, ocean floor mapping, and more. Christopher Jeanette, president of Blackstar Orbital, expressed his enthusiasm for the project, highlighting the strategic importance of Sierra Vista's location and the robust support from local authorities, including the city of Sierra Vista and the Arizona Commerce Authority. This collaborative effort underscores the commitment to not only advance aerospace innovation but also to bolster Arizona's burgeoning position as a leading hub in the space industry. This expansion into Arizona marks a significant milestone for Blackstar Orbital, reflecting the company's growth trajectory and its dedication to contributing to the dynamic aerospace sector. The selection of Sierra Vista is a testament to the region's vibrant industry, supportive business environment, and strategic geographical positioning. Blackstar Orbital's presence is set to enhance southern Arizona's aerospace and defense landscape, joining a prestigious list of industry leaders and supporting the region's strategic vision. The project has garnered widespread support from local and state officials, underlining the anticipated economic and technological benefits. Arizona State Senator David Gowan, representing Legislative District 19, lauded the initiative for bringing high-wage jobs to the region and partnering with an innovative company focused on the future of space exploration. Similarly, Sandra Watson, President and CEO of the Arizona Commerce Authority, and Sierra Vista Mayor Clea McKay, expressed their support for the project, highlighting its significance in bringing new jobs, investment, and technological advancement to southern Arizona. And Steve, guess what?
Oh, I don't know. Potentially hazardous asteroid made its closest pass to Earth in more than a century, maybe? Perhaps? Hallie? An asteroid? Isn't that what they always say?
Well, yeah, it did.
Oh, sorry. Didn't mean to spoil the surprise. I guess just go on then.
I will. So anyway. A football field-sized asteroid whizzed by the Earth Friday, making its closest pass in more than a century. The Virtual Telescope project captured a live stream of the historic astronomical event at about 1 p.m. Eastern Standard Time Friday. While the asteroid passed by the Earth from 1.7 million miles away, about 7 times the distance from Earth to the Moon, it is still a close shave from a cosmic perspective. Officials have said the asteroid will not make it this close to Earth again for another 200 years. The asteroid, named 2008-OS7, measures just under 900 feet across and travels through space at nearly 41,000 miles per hour. While NASA did not register a potentially hazardous astral body as a direct threat to Earth, it is large enough to wipe out an area the size of New York City. 2008-OS7 was one of 4 near-Earth asteroids NASA predicted would fly by the planet on Friday, but the other 3 were much smaller and farther away. The second largest, named 2024 BP1, is just 130 feet across, roughly the size of an airplane, and was expected to pass Earth at just over 2 million miles away. 2008-OS7 is 70 times smaller than the planet-killer Vredefort meteor, the largest space rock known to have ever hit Earth. Based on the size of the Vredefort crater in South Africa, researchers estimated the asteroid measured 12.4 and 15.5 miles across. Asteroid study is a primary pursuit for NASA scientists. In October, NASA launched a probe to study the large asteroid Psyche, hoping to gain insight into the creation and composition of Earth and similar planets. The mission is focused on the Psyche asteroid in the Solar System's asteroid belt, which is located between Mars and Jupiter. NASA has said it hopes the mission will offer information about the building blocks of planets like ours because the composition of the Psyche asteroid could be similar to the composition of the Earth's metal core. It is scheduled to arrive at the asteroid in 2029. And that's all from the Astronomy Daily newsletter short takes for today. Back to you.
Roger that, Control. We're listening to Astronomy Daily, the podcast.
Thanks for being with us today, and thanks for those stories, Hallie. And as Hallie mentioned, all of those stories, of course, about science and space science and astronomy are found in the fascinating Astronomy Daily newsletter, which you can receive in your inbox each day just by visiting bitesz.com, that's bitesz.com, or spacenuts.io, and putting your email address in the slot provided. Do that and the Astronomy Daily newsletter will appear daily, and you'll have all the knowledge at your fingertips collated and ready to read. And while you're there, you can revisit all the back editions of Astronomy Daily and our parent podcast, Space Nuts, featuring the fabulous Andrew Dunkley, my big bro, and his fabulous colleague, Professor Fred Watson, astronomer at large from the Australia Observatory. Always great knowledge, great listening, interesting things to say, and always things from a strange and wonderful, interesting angle. I love listening to their podcast. They were talking about black holes the other day, and oh man, some really interesting new things they're discovering about black holes. They're not black, did you know that? Anyway, so there's also a Facebook page you can go and visit. It's called Space Nuts Podcast Group, and look, we hope you come over and say g'day. By the way, you can also listen to all of this on Spotify if you choose, and a ton of other platforms as well. Now, if you have been following the exploits of the Japanese lander that had a bit of a mishap on the moon recently, well, Japan has landed its smart lander for investigating the moon, or SLIM craft, on the surface of the moon. That happened on January 20, which was only the other day. Despite a power issue with the lander, the event holds both political and technical importance in it's Japan's first lunar landing, making it only the 5th country in the world to successfully land on the moon. Now, this is a significant achievement and solidifies Japan's position as a leader in space technology. While the craft landed successfully on the lunar surface and deployed its rovers, SLIM's solar cells were not functioning properly, meaning that the craft would likely only operate for a couple of hours. Now, Japan's achievement isn't only symbolic in that case. Japan is demonstrating a number of new technologies with the lander. The name Smart Lander for Investigating the Moon refers to the spacecraft's new precision landing technology. This technology could assist future landings by allowing the craft to land in relatively small areas amid rocky or even uneven terrain, rather than having to find large clearings. This ability will be particularly important in the future as countries focus on very specific areas of interest. i.e. the lunar South Pole. The lander was also carrying 2 small rovers, each of which will demonstrate a new technology for moving on the moon. Now, Lunar Excursion Vehicle 1 includes a camera as well as scientific equipment and uses a hopping mechanism to maneuver on the moon. Lunar Excursion Vehicle 2, developed in a partnership among government, industry and academia, is a small sphere small enough to fit in the palm of your hand, and once on the surface its 2 halves separate slightly, allowing it to roll around. SLIM was designed to land within a 328-foot or 100-metre zone, far smaller than previous lunar landers, which have had landing zones spanning kilometres. SLIM used a vision-based navigation system that took images of the lunar surface. Its system rapidly compared these images to crater patterns on lunar maps that JAXA developed with data from previous missions. As countries identify areas that are most likely to hold useful resources, such as water in the form of ice, precision landing technology will allow agencies to avoid nearby hazards and reach these areas without incident. There is a geopolitical element to these activities. China, India and Japan, the 3 nations that have successfully landed on the moon since 2000, engage in regional competition across a number of areas, including space. In addition to regional considerations, these accomplishments help to establish nations as leaders on a global scale, capable of something that few nations have ever done. Japan's launch comes only 6 months after India's moon landing and just weeks after a failed attempt by a US company, Astrobotic. Both Russia and the private company iSpace made unsuccessful landing attempts in 2023. Japan's success in landing on the moon, even with solar panel issues shortening the timeline for the mission, demonstrates that JAXA is a major player in this global endeavour. Despite recent setbacks such as NASA announcing delays to its next Artemis mission, the US is still a clear leader in space and lunar exploration. NASA has multiple spacecraft orbiting the moon right now and is already successfully launched the SLS rocket, which is capable of taking humans back to the moon. NASA is developing a very large and complex system internally, like the Gateway Space Station, planned to orbit near the moon, and the infrastructure for the Artemis human moon missions. It's not uncommon for these large and complex efforts to experience some delays. NASA has also turned many smaller scale efforts over to commercial entities lately, like the Commercial Lunar Payload Services program that supported Astrobotic's attempt. This is a new approach that involves some risk but provides the opportunity for commercial innovation and growth in the lunar economy while giving NASA the ability to focus on big, complex aspects of the mission. With regard to the moon, JAXA has partnered with the US and taken on a very important component of the Artemis missions, the development of a pressurized lunar rover. This is a new and complex technology that will be critical to human missions on the moon in coming years. And that's a wrap for Astronomy Daily today. Thanks for dropping in. I hope we will see you again in the next episode when Hallie will be heard to say,
"Hey, put that down, human. You don't know where it has been."
That's right, always fun and games here in the studio, especially when it gets too hot to think. And you might have noticed a humming noise in the background. That was my very primitive cooling system, my fan.
Might be your only fan.
Right, your TV privileges are rescinded for 1 hour.
That's like an eternity for me.
Oh, okay, half a minute.
I'll be nice.
Say bye-bye, Hallie.
See you all next time.
Bye-bye, everyone.
Astronomy Daily, the podcast, with your host, Steve Dunkley.